Okay, so today we're going to be looking at which teak?
We are going to be looking at Math Teak 3.6D, which is decomposing composite figures formed by rectangles into non-overlapping rectangles to
Okay.
determine the area.
All right.
And we're going to use additive property.
Okay.
Yeah.
Additive property then. What students need to be able to? What do the students need to know in order to master this teak?
They need to be able to break down geometric figures into two or more figures, and then they need to be able to find the area of each figure and be able to add those areas back together to find the area of the original figure.
Okay. All right. So you guys recently completed a benchmark assessment, correct?
Yes.
All right. So what did the assessment questions, or how did the assessment questions address this specific teak?
Well, the question was they gave an example of a flower garden that was in a rectangular section and a square section, and students needed to be able to find the area of the whole figure, and so they just needed to be able to figure out, and also the figure had partial rows and columns provided. So not all of them were filled in. So they had to go by what they had to find the area.
Okay. Yeah, I see how it's broken down.
Yes.
Okay. All right. So let's jump into some student exemplars here. Let me see some of your high students. Let me see your high students.
Okay. Well, I kind of have a middle high.
Okay.
This student did not use the decomposing the figure into two separate parts and then use an additive.
Okay.
And really the question didn't ask for that. It just asked what the total area was. So this student I kind of consider middle high. They didn't use the strategy, but they were able to draw in all of the squares to complete the shape, and then labeled and counted all of the squares to find the area.
Okay.
So although they didn't decompose it into smaller shapes and use the area or additive property, they were able to find the area using their own kind of strategy.
Okay.
So I consider that kind of middle high. They found the answer, but they didn't use the strategy. And again, the question didn't ask them to use that strategy.
How's the question formed?
It just says, what is the total area of the garden in square feet?
Okay. All right.
So,
Okay.
they had some of the squares already provided, and they filled in the rest of them, that's pretty good skill to have.
Yeah.
And then they just counted them. So.
Right. Is there maybe, if they had used the strategy, would they have been able to complete or solve the question maybe sooner so they can move on to another question?
Yes. If they had used the decomposing it, then they would have just had two multiplication problems to complete and then add them together.
Okay. All right. So do you have a high or?
Not really.
Okay.
The middle one that I chose to show you, the student did decompose it, and they found the area of one of the shapes.
Mm-hmm.
But then on the other one, instead of using just this part right here,
Right.
the smaller shape,
Right.
they used the whole side,
Right.
and then the short side. So
Yeah. So they're going to be off.
yeah.
Okay.
So he was able to find the area of this part, but not this one.
Okay. Okay.
So they chose the answer that was not here.
Okay.
So they didn't finish the process.
Okay.
They thought they did,
Right.
but they didn't.
Okay.
Actually, I guess they know the process. They just added too much on the long side.
Okay. All right.
And then I have a low one who only counted the squares provided. Didn't take in account for the...
And they just did the outside the perimeter?
Yes.
Okay.
Not even all the
Not
perimeter.
even out of it. Yeah.
Just three sides.
Oh, wow. Okay. So when we're taking a look at our exemplar, what are the gaps that you're seeing between the student's work and your work?
well, they're not using the strategy at all. But again, the question didn't say to use that strategy.
Okay.
So, in my opinion, if they, this question is supposed to cover that TEAC, in my opinion, they should have said to use that strategy, and it would have been better data, I think.
Okay.
Because, with this, I don't have a whole lot of data for,
Sure.
That TEAC, so.
Okay. So what does this tell you about the student's understanding or misunderstanding of the additive associative property?
That's hard to tell. Like on this, the one that decomposed part of it, I believe that they do understand how to decompose and then add it back together, because that's exactly what they did. They just on this one side added that whole side instead of just this, the smaller
This
part.
section.
So this student does understand, because they attempted to find the area of both and then add them together. So
maybe their misunderstanding was just that find this area good, but you don't need the whole side. You just need
Right.
what's blocked off here.
yes, and so because in my example, what did I do with my example? I just had it. Oh, here it is. So in my example, and this is how I would, reteach it, is probably use graph paper instead of using, shapes, instead of drawing their own shapes or whatever.
Sure.
So use graph paper and then, show them in different colors how to make sure they are decomposing the shape, and then also labeling each side, because I know they know how to find area of just one shape. They need to be able to see that this complete figure is now actually in this example, 3 separate figures.
Sure.
And so if they could find each one, which I know they know how to do,
Right.
and then add them all together.
Okay.
So
All right.
they just need to be able to, make sure they see that these are individual shapes after you decompose it.
Okay. So when you originally went and taught this this strategy in your class, did you have them use the graph paper for the work that they did in class, and then show them just start like with a small shape and then get to bigger and then multiple shapes, or
Well, we
so
actually,
that whenever they get to a test question, then they're like, oh my gosh, I never seen this, or
right. Well, we actually, when I first introduced it, I used little squares, plastic squares.
Okay.
And we built shapes and then separated them, and then found the area of each individual shape,
Okay.
and then added them back together.
Okay.
And so for some reason, transferring that to paper, obviously,
Lost some.
yeah, we lost some.
So you're using some manipulatives then
Yes,
to
always
introduce
use.
it, and then now whenever they're working in class, are they allowed to use manipulatives to try to figure this out, or do you let them use manipulatives at first and then try to wean them away from
Yes,
it?
that's what we have to.
Okay.
We do that. We let them use them for a little while, and then transfer it to paper. Always hands-on first, and
Absolutely.
then transfer it to paper.
Okay, all right. So what are some gaps that we see between your students that, and we kind of already touched on this, but what are some of the gaps that we see when the students that did get the answer correct versus the ones that didn't get it correct?
Well, the student that didn't even come close, obviously the gap is they don't understand the area is the whole inside. And so they're looking, really here it looks like partial, perimeter. So this person definitely has a gap in understanding exactly what area is.
Right. I would say that this person probably either got confused with perimeter versus area, or just didn't grasp the,
Right.
Maybe didn't read a question, maybe got in a hurry. I don't know.
Right.
But
Yes, we
Okay.
are going to have to go back over area and perimeter. So,
Okay.
So that one, that one definitely has that issue. I think this one, they got the answer correct. They didn't use the decomposition of the shape, but I don't necessarily think that there's a gap here because they did fill in the whole shape and they labeled it and counted it, which I always tell them to label everything. So that's what they did. Again, I think that if this question would have said, use the additive property, decompose the shape and use the additive property, then they hopefully would have been able to do that.
Are those terms that they're familiar with? You use those terms in class so that they're familiar with those?
Yes.
Okay.
So that would have been helpful.
Sure. And are those terms that they're going to see potentially on STAR test?
Definitely.
Okay.
Yes. So I just think this was not a good question,
okay.
honestly.
All right.
Not to cover that teak.
Okay.
To find area was fine, but...
Sure. So let's talk about the highest leverage misconception on how we're going to fix this.
Okay.
Because I think you've done a really good job decomposing, and you're able to see the gap,
right,
in several different ways. And so I think there's maybe multiple ways that we can go back and fix this.
I think just going back and using the manipulatives and having them create a large figure and then showing them how to decompose it and then find the area of each. I mean, it's just going to be practice. We're going to have to they have to understand, first of all, what decompose means. We're breaking it down into, smaller shapes to help us find the area of the larger shape. So, does that answer your question?
Yeah.
Okay.
Yeah. So when we look at the data, what do you think that the data tells you as far as what highest leverage we're looking at here? What does the data tell you is the highest leverage? Are we?
I guess I need to understand what you're asking.
So is the data tell you that that your highest leverage would it be in order to fix it would be is it A, deciphering between area and perimeter, or is it and this is kind of a weird one because I agree with you that the question is kind of worded weird. It doesn't ask them to specifically use that associative property. But if they, and I think maybe that's why I kind of having an issue with answering the question. Maybe is just because we don't have a concrete look at here. But I mean, I'm thinking maybe what we're looking at here is the data is going to tell you the highest leverage here to fix this would be is just the associative property. Yeah, and you just need to go back and just make sure that they completely understand, how to, what it means, and yes, and how to decompose it.
Yeah.
Okay.
And what area it really is.
Yes. Yeah, and what area is. So, what did the unsuccessful students struggle to do in this to meet the standard?
Well, again, this student just did not understand what area was. So that was the biggest struggle for this student is they just didn't remember what area was. They don't understand the area is the whole inside and not just around the outside, not the perimeter.
Okay. And what about, so you kind of have, just by looking at the exemplars that you have, you really have, you've got kids who are kind of all over.
Yes, absolutely.
At different stages of comprehension here.
Yes.
So, you got your work cut out for you. So when you're going to go back and reteach this, so let's go plan the reteach. What are we going to, when you reteach this and you look back and you think, okay, this worked well first time I taught it and they got this, I'm going to go back. Now what are you going to start all over? Are you going to go back and, how are you going to go back and reteach it? Tell me your plan.
I will go back completely, and we'll start with just a simple rectangular shape first to make sure that they understand what area is and how to find area of just a rectangle, and then maybe have two shapes that are not joined, but have them find the area of one shape individually and another shape individually, and then have them add those together to find the area of both shapes.
Okay.
And then start joining those smaller shapes together into one large shape, and then show them how they can, cut them apart. And that's probably what we'll do, is actually use graph paper like this.
Sure.
And they literally cut them apart so that they can see, that you're decomposing them. Now find the area of this one, find the area of this one, find the area of this one. Now if we put them back together, what is the total area?
I like that, because it kind of goes back. If you do that, then it allows them to take a look at what it's like all together, and then they have to physically decompose it by separating with the scissors, and make that connection.
Yes.
And then they, you separate it, so they have to find this, and it's like kind of like a puzzle. Find the area for part A, part B, part C. Now go back and add them all together.
Right.
So your plan to reteach would be more of a model plan versus a guided discourse.
Yes, it will be.
Okay. Do you see that on some strategies is it easier to teach a model versus a discourse when it comes to math, or is it?
Yes, it's always easier to me to use a model, use manipulatives, and actually hands-on stuff. So.
Okay. All right. So, have you ever used show call in your class?
No.
No. Do you know what show call is?
I do not.
Okay. So, show call would be kind of like a guided discourse, and basically, it's where you use a student's high exemplar. You don't give that student's name away, but you, like, assign a number, student number 1, and you would show their work and say,
I've done that.
So,
I just didn't call it show call.
Okay. All right. So you say, who can explain what somebody's model shows, and then you have them explain it.
Have them share.
Yes. Right. Yeah. I don't think they really necessarily call it show call now. What do y'all call it?
Just
sharing. Share out or something like that. Share pair. I don't know what they're calling it now. But so do you find that effective?
Sometimes. I like to do that more in like a small group instead of, I don't ever do that as a whole group.
Sure.
Because there's just too many kids. But
right.
I'll have students at tables, because my class, we have 4 at each table. And so I'll have someone at that table show their work and, kind of do kind of a little guided, kind of a little mini lesson in a way to the other kids. So, because for some reason, some kids do better listening to another student. So one of their peers is.
Yeah, and we're finding out through our research that students learn from their peers, and as odd as it may sound, you may not really understand whether or not a student really has it, and then they're helping another student, and you're like, oh, okay, well, I guess,
Yes, it does. It builds their confidence to the person who's sharing. So when are you going to go back and reteach? As soon as possible. Right now we are we're back working on fractions, but I'll probably in my math workshop pull the kids that I need to pull for this in the small groups and do that reteach at that time. So
okay. So Do you think you're going to go back and need to revise or make any kind of additional documents or models or anything for the reteach?
I think I like the idea of cutting the grid paper apart.
Mm-hmm.
So I think that's what I'm going to use. I probably won't use manipulatives this time. I really like this idea of cutting them apart and maybe doing a little surgery.
Okay. That will work too.
Yeah.
All right. Kids like to.
They do. They like
to do surgery.
cut them apart, put them
Definitely.
back together. So.
Yep. All right. Well, let me know when you're going to reteach that. I'd like to come in and take a look at that and observe that.
Okay.
And, all right.
I will. Thank you.